Hello everybody, I would like to welcome you to our 28th video in the pre-algebra playlist. And in this video, we're going to go over the concept of least common multiple. Now, just like how the greatest common factor is often referred to as the GCF, the least common multiple is similarly referred to as the LCM. So before we begin finding the least common multiples between two numbers or two expressions, let's first go over the definition of what a multiple is. Basically, a multiple is a number that is a product of one number and any other non-zero whole number. So what do I mean by this? Well, if you have some number such as 4 and you multiply that number by, let's say, some number 3, and that gives me 12, then 12 is known to be a multiple of the number 4. Similarly, I could have rewritten this as 3 times 4 is equal to 12. In this case, I can say that 12 is a multiple of the number 3. It is very possible for some number to be a multiple of more than one number. So in order for you to get a better understanding of what multiples are, let me list the first 10 multiples of the number 2. Similarly, the first 5 multiples of the number 3 are as follows. By now it should be clear that a single number can have infinitely many multiples. So by just looking at these two rows of multiples over here, if I ask you to find the common multiple between the number 2 and the number 3, you could say that one of the common multiples between these two numbers is the number 12. But sometimes a common multiple may not be the least common multiple between any two numbers. So now let me go over the steps that are required to find the least common multiple between any two numbers. In the first step, you need to figure out the prime factorizations of all of the numbers that you're trying to find the least common multiple of. After that, you need to isolate the greatest power of each of the factors for each of those numbers. And lastly, you need to multiply all of the findings for step number 2. So I hope these 3 steps have confused you a little bit. So in order to clear up the confusion, let me do a few examples. So in this first example, let's say I want to figure out the least common multiple, or the LCM, between the numbers 18 and 36. So I need to follow the steps from the last page. The first step tells me to figure out the prime factorizations of both of the numbers. So now let's first figure out the prime factorization for the number 18. The smallest prime factor for the number 18 is the number 2. So I can break apart 18 into 2 branches. On the first branch I'll have the number 2, and on the second branch I'll have the number 9. Since the number 9 is a composite number, I need to do more work to it. The smallest prime factor for the number 9 is the number 3. So I can break apart the 9 into 2 branches, and on one branch I'll have the number 3, and on the other branch I'll also have the number 3. So the prime factorization for the number 18 is 2 times 3 times 3. I can rewrite this using exponents as 2 times 3 to the power of 2. The smallest prime factor for the number 36 is again 2. So on one branch I'll have the number 2, and on the other branch I'll have the number 18. Since 18 is a composite number, I need to find the smallest prime factor for the number 18. In that case, it is again 2. So I break apart 18 into 2 branches, and on one branch I have the number 2, and on the other branch I have the number 9. Since 9 is a composite number, the smallest prime factor for 9 is 3. So I break apart 9 into 2 branches, and on both branches I have the number 3. Therefore, the prime factorization for the number 36 is 2 times 2 times 3 times 3. This can be better represented using exponents as 2 to the power of 2 times 3 to the power of 2. Now that I have my 2 prime factorizations, I can move on to the second step from the last page. The second step tells me to use the greatest power of each of the factors from the prime factorization. In this case, I have the number 2 over here and the number 2 over here, meaning 2 is a factor of both 18 and 36. In the prime factorization of 18, the highest power of 2 is to the power of 1. So I have 2 to the power of 1 for the prime factorization of 18. On the other hand, for the prime factorization of 36, I have a factor of 2 to the power of 2. So I'm going to use that over here, since 2 to the power of 2 is greater than 2 to the power of 1. But in both of these cases, I have a factor of 3 to the power of 2 for 18 and 3 to the power of 2 for the number 36 as well. So it doesn't really matter which one I end up picking since they're both equal. And then I move on to the third step, which tells me that I need to multiply the greatest power of the factors from step 2. So I have 3 to the power of 2 over here and 2 to the power of 2 over here. So I need to multiply these two together. Now when I simplify this over here, I get 4 times 9, which gives me 36. Therefore, the least common multiple of the number 18 and 36 is 36. In this example, let's say I want to figure out the least common multiple between the numbers 8, 14, and 5. The first thing that I need to do is figure out the prime factorizations of all of these numbers. The prime factorization for the number 8 starts off by breaking apart 8 into two branches. On one branch I have the number 2 and on the other I have the number 4. Moving on, I can break apart 4 into two branches, and on both of the branches I have the number 2. So the prime factorization for 8 is 2 times 2 times 2. The prime factorization of 14 starts out by finding the smallest prime factor for the number 14. In this case, that number is 2. So on one branch I have the number 2, and on the other branch I have the number 7. Now since both the numbers 2 and 7 are prime, I am done with my prime factorization. Lastly, the prime factorization of 5 cannot be done because 5 is in itself a prime number. Therefore, the prime factorization of 5 is simply 5. Now I move on to the second step and figure out the greatest power of each of the factors. In the prime factorization of 8, I have a factor of 2, which has a power of 3. Also, I have a factor of 2 in the prime factorization of 14. But in this case, the power of that factor 2 is only 1. And I have no factor of 2 in the prime factorization for 5. So the factor that I will be using for the third step is 2 to the power of 3 because that is greater than 2 to the power of 1. Moving on, I have no other factors remaining in the prime factorization of 8. On the other hand, I have a factor of 7 that remains in the prime factorization of 14. So I will be only using this factor, which is 7 to the power of 1, in my third step. Similarly, when I move on to the prime factorization of 5, the only factor that I have is that of 5. And since the greatest power for the factor of 5 in all of these prime factorizations is simply 1, I'll be using that in my third step. All that remains for me to do now is multiply these three numbers over here. When I do that, I get 2 to the power of 3 times 7 times 5. This right here is the same thing as saying 8 times 7 times 5. I leave it up to you to verify this, but this right here equals 280. Therefore, the LCM of 8, 14, and 5 is 280. Let's say I want to figure out the least common multiple of 24a to the power of 3 and 16a to the power of 5. Now, in order to figure out a prime factorization for a variable expression such as 24a to the power of 3, all you really need to do is figure out the prime factorization of the number or the coefficient, which is 24, and then multiply that by the variable, which is a to the power of 3. So, I first figure out the prime factorization for the number 24. I leave it up to you to verify this, but this right here is the prime factorization for 24. So another way of writing the prime factorization of 24 using exponents is like this over here. And to that, I simply multiply the variable, which is a to the power of 3, like this over here. So this right here is the prime factorization for 24a to the power of 3. Now similarly, let's figure out the prime factorization for 16 times a to the power of 5. I first need to figure out the prime factorization for 16. I leave it up to you to verify this, but the following is the prime factorization for 16. This can be rewritten using exponents as simply 2 to the power of 4. And to that, I simply multiply the variable, which is a to the power of 5. I have a factor of 2 over here and a factor of 2 over here. I have a factor of 2 to the power of 3 in the prime factorization over here, and I have a factor of 2 to the power of 4 in the prime factorization over here. So in this case, I will be using this right here, which is 2 to the power of 4 in my third step, because that is greater than 2 to the power of 3. I have a factor of 3 over here, but no factor of 3 over here. So I'll simply be using the factor of 3 to the power of 1 in my third step. I have a factor of a to the power of 3 over here, but a to the power of 5 in this factorization over here. Therefore, I'll be using a to the power of 5 because that is greater than a to the power of 3 in my third step. Now all there is left for me to do is multiply these three numbers inside the circle. And when I do that, I get 2 to the power of 4 times 3 to the power of 1 times a to the power of 5. When I simplify this, I get 16 times 3 times a to the power of 5. When I simplify this further, I get 48 times a to the power of 5. So this right here is the least common multiple of 24a to the power of 3 and 16a to the power of 5. So that's it for this video. I hope you keep on working hard, and I'll see you in the next video.